number 8. The curve has equation y equals f of x, where x is positive, greater than 0, so it's positive. The point P 412 lies on the curve. If the point lies on the curve, you can substitute it into the curve equation. Given that f prime of x, this is the derivative of the curve, where k is a constant. So they are giving you the derivative. And second thing, the equation of the tangent to the curve at P has equation y equals 10x plus c, where c is a constant. You know that, let's say this is how the curve looks like, right? Just an idea, okay? No, it will not look like that, but I'm just drawing it to make you understand this point here, okay? Let's say this is the curve equation. Now they say the point P, let's say, and this is the point P, okay? They say the equation of the tangent to the curve at P has equation. Okay, when you will draw the tangent at the curve at the point P, this tangent has an equation y equals 10x plus c, okay? And you know that they are giving you the derivative function. So the derivative, basically derivative of the curve is the gradient of that tangent line. So what is the gradient of this tangent line? That is 10, okay? Gradient is 10, which means that you can substitute this gradient in place of f derivative of x, because f derivative is the gradient too, right? F derivative represents the gradient of the curve at that specific point. So yeah, you can substitute this point into the gradient. Let me just write it. You know that f prime of x is given to be 3 root of x plus kx square, okay? What we can do, we can substitute the point into the, the derivative and replace the derivative with 10 at the same time, okay? So 10 is equals to 3 root of x. In place of x, I will then substitute the point P values. So my point is 4 and 12. X coordinate is 4. So I'll just write root of 4 plus k 4 square. Okay. So 10 is equals to 3. Root of 4 is 2 plus 4 squared is 16k. We can simplify to get the k now. So 10 equals to 6 plus 16k. Move 6 to the other side. That becomes 4 equals to 16k. Now divide both sides by 16. So k will be 1 over 4. Okay, that is your k value. So you use the given points to calculate the k, right? Part A was to show that k is equals to 1 by 4, and that's what we did. Part 2, this was the part 1. Part 2 is find the value of c. Now we have to find this value of c here. You can see that. Since you know that if the line equation for the tangent line equation is given, and we have to find that c, and that tangent is passing through the point P, so you can substitute that point into the tangent equation, as that point is lying on the equation of the tangent. Okay, so now we know that y, part 2 is, we know that y is equals to 10x plus c, and point P, which is 4 and 12, lies on the line as well. So we will substitute the values. We will substitute y as 12 is equals to 10 times x as 4 plus c. Okay, now we will solve it. 10 times 4 is 40 plus c. Move 40 to the other side. So 12 minus 40 is c. C will be, what is 12 minus 40? Minus 28. Okay, here is the value for c. Now we have part B. Hence find the value of the f double prime of x. F double prime at the point P, it's a double derivative. We already know the first derivative, which is part B is, we already know the first derivative is 3 root x plus kx square. Plus kx square. Now we have to find the double derivative. Okay, we are just gonna replace the value of k as well. We got k as 1 by 4 So I'll be replacing k with 1 by 4x square here. Okay, that is the first derivative. I will differentiate it one more time to get the second derivative. Okay, so let's differentiate with respect to x. This is the root of x, so the power of x here will be to the power of 1 by 2. Yeah, so what does the derivative say? Multiply the power with the starting number. So 1 by 2 times 3 will get you 3 over 2 and make 1 less in the power. So 1 by 2 minus 1 will be negative a half. So x to the power of negative a half plus power times the starting number. So 2 times 1 by 4 will be 1 by 2 obviously, and make 1 less in the power. 2 minus 1 will be 1. Okay, so this is the second derivative. They said find the second derivative at the point P. We know the point P is 4 and 12. We will now substitute this point into this equation, which will then become f double prime of x is equals to 3 by 2 and 4 to the power of negative 1 by 2 plus 1 by 2, 4 to the power just 4. Okay, so 3 by 2, 4 to the power of negative 1 by 2, you can put it in the calculator. So 4 can be written as 2 power 2, negative 1 by 2, you just cancel it, 2 to the power negative 1, 2 to the power of negative 1 is same as 1 by 2. Okay, so you write it 1 by 2 plus 1 by 2 times 4 will be 2. So that becomes 3 over 4 plus 2. Yeah, and f double prime at this P will be so 4 times 2 is 8 plus 3 is 11 over 4. Okay, that is the second derivative at this point 4 and 12. Okay, we done with part B. Now part C. Find f of x. Okay, listen, whenever, okay, that is what 4 marks, so you're gonna do integration here. I mean, whenever they will give you the first derivative, we have to apply the integral to remove that derivative there. Okay, we know part C is we have to find f of x curve. Okay, we have to find the curve basically, and they're giving you the point which is lying on the curve, which is 4 and 12, and we know the first derivative is 3 root x plus kx square plus kx square. K value is 1 by 4, so 1 by 4x square. That is the first derivative. To remove the derivative, we will apply integral on both sides, because integral can remove the derivative. So we will get f of x. And how do, if 3 is just a constant, so you will write 3 as it is. And how do you apply the derivative to root x? So you add 1 to the power of x. Since this root x can be written as x to the power of 1 by 2 now. So you will then write x to the power of 1 by 2 plus 1, add 1 to the power, that makes it 3 by 2. Do the same thing in the bottom. Plus 1 by 4 is a constant, add 1 to the power, so 2 plus 1 makes it 3 over 3 plus c. Yeah, so our f of x will be, you just take the reciprocal of fraction which is in the bottom, so that becomes 2 by 3 times 3, x to the power of 3 by 2 plus 1 by 4 times 3 will become 1 over 12, x to the power of 3 plus 3, c. 3 gone, it is 2 x to the power of 3 by 2 plus 1 by 12 x to the power of 3 plus c. That is your f of x. Now we have to find the value of c as well, and you know the point which is lying on the curve, which is 4 and 12. So we can substitute this point in the curve equation since it is lying on it. So I will replace f of x with 12 because my p points are 4 and 12. And 2, and replace x with 4. So 2 times 4 to the power of 3 by 2 plus 1 by 12, 4 to the power of 3 plus c. Okay, you can put it in the calculator. Let me see if they have put the restriction. Yeah, solutions relying entirely on the calculator technology are not acceptable, but you know that is for, you cannot use direct integration and differentiation on the calculator. You have to do some simplification as well. So here we can put the things in the calculator. 2 times 4 to the power of 3 by 2, or 4 can be written as 2 power 2, and then it has the whole power of 3 by 2. This 2 can be cancelled out, it is 2 power 3. 2 power 3 can be written as 8. Okay, so I can write 2 times 8 here, plus 4 power 3 is 64, so 64 over 12 plus C. Now you do 12 minus 2 times 8 is 16, and minus 64 over 12 is equals to C. You now put the whole thing in the calculator. That makes it 12 minus 16 minus 64. I put the fraction 64 divided by 12. That makes it minus 28 over 3. Okay, so here is your C. Your f of x will then become, you just substitute the C value in your f of x. Here is your f of x, that is 2x to the power of 3 by 2 plus 1/12 of x cube plus C, which is minus 28 over 3, and here is your required curve. Okay, and that was the part C, and that here's your whole question number 8, the calculus portion. Okay, now we're gonna proceed to question number 9. All right.